now let's look at a simple instance of the mean value theorem here. So this is one simple example, a simpler version. So hang on, bear with me. So let's look at this here. Hang on. So instead of f of b being here, if we make f of b to be the same as f of a here, so f of b, so this here is f of b here. So if we make f of b, so this is a simpler version of the mean value theorem. It's saying that if f of a is the same as f of b, then there exists a c. There exists a c where the actual function there exists a value of c where the gradient of the actual function will be 0. So this is pretty much the same as this, where you if you make f of b the same as f of a, then this bit here will be 0, and well, the gradient here will be 0 basically. But what it's saying is that there exists a value of c here where the gradient must be 0, at least 1 0. So what it's saying is that it's like me asking you to draw a function that crosses a and b. You see, no matter what function you draw, there must be somewhere in between a and b, there must be a point where the gradient will be 0. Okay, so you see, right at this point here, the gradient is 0. Right, there happens to be more, but it's saying there must exist one value of c, at least one value of c where the gradient will be 0. So it's like me asking you to draw another function. So it's like, if you were to draw something like this, joining a and b here, you see right here, the point here is that there must be a value of c in between a and b where the gradient is 0. No matter what you do, you're going to need to create a 0 gradient somewhere in between a and b. So no matter what function you draw, you see there's a gradient 0 here, there's a gradient 0 here. So this is pretty much, unless, well, even if you draw this here, there is a point here where the gradient is 0. But the point here is that no matter what you do, you're always going to get somewhere in between. There must be a gradient of 0 somewhere in between. So no matter you try and break this down, it's see right here the gradient is 0. So this here is actually called Rolle's theorem. Okay, but I will elaborate more on this next time round. Okay.